Okay, so we'll have a look how to do the question 2. Okay, so now I want to find the LU. So I let the 1, 2, 3, -1 to 2, and then -2, -16. Oh, I does not share. Sorry. Okay, so I'll continue. Okay, so -16, -15. So this one is equal to L times U. Okay, so L times U, so I have L11, L21, L31, 0, L22, and then L32, and then 0, 0, and L33. Okay, times your U. U will be 1, 0, 0, 1, 0, and then 1. So this one will be U21, sorry, U12, U13, and the U23. Okay, so now is I want to find all of this one. So actually you can direct okay lah, I do step by step lah. Okay, I just show you why. This one, how come they can direct assume this one? Okay, here. How they get the first column of L is equal to the first column of A. Okay, so now let's see. They said this one, L11, L21, L31 is equal to 1, 2, 3. Why? Okay, so now I take this one times this one. So what happened? L11 times 1 is L11 is equal to the first number, which is 1. So I have the first answer. Okay, now I take this one, this row. Okay, I take this row times this one again. So I have L21 is equal to L21 times 1 plus L22 times 0. So I have L21 is equal to 2. And then L31, so I take this one times this one. So I have L31 is equal to 3. So that's why they said the first column of L is always equal to the first column of A. Have a look. Okay, so after that, they said the first row of U is equal to the first row of A divided by A11. Okay, so what's mean by this? They said first row of U, this one, is equal to first row of A divided by 1. So that means now your U12 will be negative 1. Your U13 will be 2, negative 2. Okay, so now let's see why they said so. Okay, so now I take L11 times this one. So if you take L11 times this one, okay, you take the first row times the second column. So you will have L11 divided by A11. Yeah, correct. Okay, L11 times the U12 is equal to 0. Is equal to this one times this one is equal to negative 1. So that means your U12 will be equal to negative 1 divided by 1, which is negative 1. So that's why we said, okay, this row and this row will be the same divided by 1. Okay, and then again lah, U11 times U13 is equal to negative 2. So that's why we know U13 is negative 2. Okay, keep repeat the same thing. Try to get the L22, L32, L33, and also the U23. Okay, so just now we take this one times this one. Okay, we take this one times this one times this one. So first column is already done. Okay, second column. Okay, I take the first row times the second column, third column. So now I take the second row times the second row times the second column. So L21 times the U12 plus the L22 is equal to 2. So that means, okay, L21 is 2. U12 is negative 1. So L22 will be 2 plus 2, which is 4. Okay. And again, now I take the second row times the third column. L21, U13 plus L22, U23. Okay, second row, third column, so negative 16. L21 is 2, U13 is negative 2. So 2 and negative 2, negative 4. Negative 4 move to the back, become plus 4. Plus 4 become negative 12. So negative 12. So 4U to 3 equal to negative 12. So I know that U to 3 is negative 3. So U is done already. Now left the L. U32 and U33 not yet done. Okay, so maybe I take the third column times the second column, second row. Sorry, third row times the second column. This one. So thirdly, this one times this one. equal to 2. L3, 3, U1, 2, -1. So -3, -3 become 5. And then third row times the third column. L31, U13, L31, U13, L32, U23, L32, 5, U23, -3, plus L33 equal to -15. So L33 equal to -15, so equal to 6. So that means my A here, my L here will be 1, 2, 3, 0, L22, L22, where's my L22? 4, L32, 5, L33, 6. One, -1, -2, -3. Okay, so check whether correct or not. 1, 2, 3, 4, 5, 6. 1, -1, -2, 1, -3, 1. Okay, have a look. Try to understand. Okay, so after I get the U and L, now I can do the, okay, I want to find the A. How are you going to find the A? Sorry, this one. Okay, the A will be equal to L and then times U. So how you get the L? Okay, in order to get this one, Sonia, okay, in order to get the L, okay, you just need to take the 1 times the 4, 1 times 4 times the 6. Okay, U itself is 111 lah, so no need to try lah. So you get the answer as 24. So that's why you see this one, the answer should be 24. Okay, so in order to get the magnitude or modulus, just very simple. You take the 1 times 4 times 6 times a 1 times a 1 times a 1. So nothing changed lah. So only you need to find the modulus of A, okay, or magnitude of A. Okay, next I want to solve the XYZ. Okay, I want to solve the XYZ by using this one. So I want to solve the XYZ. So I know that, okay, again lah, I have AX. If you can't remember, you just do like this. AX equal to Y. And then we change the A into the LU. So LU, X equal to Y. Okay. And then we change it to this one as LA, LB. Okay lah. UX equal to A. Sorry, this one should be B, not Y. My mistake. X equal to B. So LUX equal to B. So UX equal to Y. Okay. UX equal to Y and okay, Ly equal to B. So I have these two equations. So now we want to find the Y first. Okay, sorry. We want to find the Y first. So how are you going to find the Y? We use Ly equal to B. So Ly equal to B, what is your L? Your L is this one. So this one times your Y, which is Y1, Y2, Y3, equal to your B. What is your B again? Your B is 0, negative 20, and negative 13. Okay, so here we try to solve the y1, y2, y3. So 1 times y1 equal to 0. So y1 equal to 0. Okay, 2 times y1 plus 4y2 equal to negative 20. So that means y2 will be negative 20 divided by 4, negative 5. And then 3 times y1, which is 0. 5 times y2, which is negative 25. Negative 25 plus 6y3 equal to negative 13. So y3 will be 12, 2. Okay, so after you get the y1, y2, y3, now we put into the first one. So what is your your u again? So u times your y is 0, negative 5, and then 2 is equal to your, your ux equal to y. Ux, x, y, z. They use x, y, z, is it? Yeah. Is equal to your y. So 0, negative 5, and 2. So you can easily get 1z equal to 2. So z equal to 2. Next one. y minus 3z equal to -5. Okay, and then what is your z? 2. So 2 become -6. -6 you move here, so your y is 1. Okay, now we do the x. So 1x minus y minus 2z minus 2z, so minus 4 is equal to 0. So that means your x will be 5. So that means your answer will be 5, 1, 2. Yeah. Again, have a look. And please ask if you have any questions. Sorry. Okay, so just now is LU decomposition. Now we have a look on the another method, which we call LLT decomposition. Okay, basically their idea is the same. Okay, just one is LU, one is LLT. Okay, so in this one, just now we need to find the L, we need to find the U. Here no need, you just need to find the L will do. Okay, so again basically their idea is the same, but before that, in order to use a LLT decomposition, okay, they have certain condition. Okay, so now okay, we have a look first. Principal submatrix of A, okay, are the submatrix. Okay, this one later we will see. Okay, obtained by blah, 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 blah. Okay, so for example, now we try to see what is principal submatrix. Huh? So let's say this one, I have the A as this one. So principal submatrix, if I want to find the A1, will be this one, which is 4. If you want to find the A2, will be this one. First two row, first two column. Okay. A1, that means the first row, first column. A2, that means the first two column, first two row. So 4, 2, 2, 17. And then A3 will be this one. Okay. So now the definition. We said it is positive definite. Okay. If the determinant of every this one and this one and this one is positive. If everything of this one is positive, then we set positive definite. Because positive definite only you can use a LLT decomposition. Okay, later we'll see. Okay, so now we have a look on this example. So A1 is 4, A2 is 4, 2, 2, 17, so which is 16. 64. A3 is holding here is 1600. So everything is positive. So we set A is positive definite. If this one, okay, if it is positive definite, okay, symmetric and also positive definite, then we can use LLT. What is symmetric? You cut the line, this one and this one is the same, this one and this one is the same, this one is the same. Okay, must be positive definite, must be symmetric, then you can use this way in order to, you can use an LLT. Okay, so first we need to make it into the LLT. We need to make this one into the LLT. So what is LLT? LLT will be this one. L is the same, but LT will be transpose of this one. So row become column. First row become first column, second row become second column, third row become third column. So the things you need to find might be less a bit, okay, but they have the condition. First must be symmetric, second one must be positive definite. Okay, so we try to get the L11, L21, L31 by the similar way lah. This one I don't want to talk much lah. Okay, and then L2, L22, L32, and L33. Okay, so you must get the L first, and then the way is the same. So substitute your A into the LLT equal to B. So this one will be your Y. So that means, okay, your Y will be LTX and put your Y inside, so you will have LY equal to B. Just that simple. The idea is the same, okay? Just you need to you need to make it into the LLT. That's the difference. The rest will be the same, okay? So uh, okay, so now we try to use this Kolesky method, okay, which is LLT decomposition in order to solve this one. Okay, so we know that the A is what? The A is 4, 2, 15 of the A is this one just now they check already. It is symmetric. It is positive definite. Okay, positive and definite. Now they also had make it into the L. Okay, so we get the LLT. Okay, we get the L here. So now what we need to do is we try to find the Y by taking the L. By taking the sorry, we try to find the Y here. Okay, by taking the L times the Y equal to B. So 2Y1 equal to 14. So Y1 is 7. So 1Y1, which is 7, plus 4Y2 equal to negative 101. Hence, we get the Y2 and also the Y3. So after that, you put into the first one. Okay, you have what you have for your Y. Okay, what you have for your Y. Sorry, this one is your Y equal to your LTX. Okay, so you get the 5z equal to 5, so z equal to 1, and then continue, you get the y and x, so you will get this one. Okay, so now we try to do question 3. Now your turn to try to do the question 3. Sorry, question 3 is by using the crowd method, which is LU decomposition. This one I left it to you. This one I don't want to do. Okay, question 3 I left it to you. Now you do the question 4. OK，我下午不懂有没有时间，可能明天我再帮你问。 Okay, so now we have a look. Question 4. Question 4 and question 5 is similar. I don't want to do the question 5. Later you do the question 5. But question 5, the 4 and 5 are a bit different. Okay. So I'll do the question 4 first. Okay, so first one, this one is matrix lah. So this is because you cut the line 0, 0, 3, 3, 2, 2. So it's symmetric. Okay, A1 will be 4. A2 is 4009, which is 36. A3, sorry, will be modulus of A. Okay, let me find the determinant by using the calculator. Matrix A, 3 by 3. 4030923224. So I want to find the determinant of matrix A. So I get 47. So it is positive definite. Okay. Okay, B. I want to get the LLT. So 403 092 324 is equal to L11, L21, L31, L22, L32, L33. So this one will become L11, L21, L31, L22, L32, L33. Okay, so from here I know that 4 is equivalent to L11 square. First row, first column. So that means my L11 should be 2. Okay, so after you have the L11, let me see, this one, this one, okay. So first row, second column. So L11 times L21, so 2L21, 0, 0, so nothing, so equal to 0. So L21 equal to 0. Okay, and then 4, again, 3 is equal to this one times this one. So L11 times L31, so 2L31 equal to 3. So L31 equal to 3 over 2. 3 over 2, how come? Oh, yeah, 3 over 2. So I have L11, L21, L31. Now I don't have the L22, L32, and L33. Okay, second row, second column. Second row, second column, L21 times L21. Okay, so it's 0, and then L22 square is equal to 9. So L22 equal to 3. Okay, and then now I have L22 already. I want to find the L32. So L32, I get the second row, third column. Okay, L21 times L31. So L21 is 0, so 0. And then L22 times L32. L22 times L32, so 3L32. Okay, equal to 2. So that means my L32 will be 2 over 3. Now I want to get the L33. Okay, I want to get the L33, I get the third row times the third column. L31 square plus L32 square plus L33 square. So L31 square, so 3 over 2 square, so it's 9 over 4. L32 square is 4 over 9. Plus L33 square is equal to 4. So my L33 will be 4 minus 9 over 4, and then minus 4 over 9, and then square root answer. So 47 divided by 6. Okay, have a look. Okay, so after you get the L, you get the LT. Okay, so now I want to solve this one. Okay, so I have my L here. Okay, so again you just remember LLT X equal to B. So that means your LTX equal to Y and your LY equal to B. So we start from Ly equal to B. So this is your L times your Y, Y1, Y2, Y3 equal to your B, 15, 20, and 17. Okay, so start from the upper end. Okay, so 2y1 is equal to 15. That means your y1 will be 15 over 5. 15 over 2, sorry. Okay, 0y1, 3y2 equal to 20. So that means your y2 will be 20 over 3. Okay, 3 over 2 y1, 3 over 2 y1, so that means will be 45 over 4 plus 2 over 3, 2 over 3 y2, so 40 over 9. Okay, and then plus 47 over 6 y3 equal to 17. So we move everything to get the y3. Okay, 1 minute. Okay, so I get my y3, if not mistaken equal to 47 over 6. Okay. So after I get my y1, y2, y3, now I'm trying to get my x. So my LT will be 2, 0, 3 over 2, and 0, 3, 0, 0, sorry. 0, 3, 2 over 3. And then 0, 0, 47 over 6 times your x, which is x, y, z, equal to your y, which is 15 over 2, the 20 over 3 and sub 47 over 6. Okay, so again we start from Z. So sub 47 over 6 Z times equal to sub 47 over 6. So that means quite clear lah. My Z is 1. Okay, now 3y plus 2 over 3 because Z is 1. Okay, 2 over 3 equal to 20 over 3. So that means my y will be 20 over 3 minus 2 over 3 will be 6. 6 divided by 3, 2. And what is your x? Okay, so 2x plus 3 over 2z is equal to 15 over 2. So 6. 6. So your x will be 3. So that means your answer will be 3, 2, and 1. Okay, so question 5, I don't want to do. I will leave it to you. Okay, question 5. 1 is easy, 2 is okay, 3 is the same as 4. Okay, question 4. Just a 4 and 5 is a bit different. 4, I want to find the L inverse. The inverse still okay. You can use calculator or you can use another way. Okay, and then L inverse means what? Kolesky method is using the number 4 lah. Okay, L inverse is that means LLT. Hmm. L inverse, L inverse T, and then P. This means the inverse method. Okay, so we move everything to the back. Okay, and then times the B, then we will get the X. This one I will leave it to you also lah. Okay, if cannot do, then later I will show you the solution. Okay, so question 5 I will leave it to you. Okay, so I just continue a bit lah before. Is always 0, is always 1. Yes, this one is always 1. The LU decomposition, the LU decomposition, the modulus of U is always 1 because whatever you have 1, 0, 0. Whatever you have A, B, C, 1, 0, 0. Okay, if you want to find the modulus of this one, it will be, okay, let's say I take the first column. So 1 times the 1 times the A1B. Oh, sorry, this one should be 1. Okay, 1 times the 1, 0, 0, 1. Oh, not 0, but C. This one is C. Okay, and then 0 times AB 0, 1, but 0 times anything is 0, plus 0 times AB 1, 0, 1C again lah. 0 times anything is 0. So that's why the answer is always 1. So for U, always is 1. We don't care what is the ABC. We don't care what is the U11, U12, U13. Okay, so it's always 1. And then next one. What? This one is what? 3 by 3 multiplication. Apa ni? Oh, okay, you don't know how to times already. Okay, I just let you know lah. Should be if let's say 1, 2, 3, 4, 5, 6, 7, 8, 9 times your A, B, C, D, E, F, G, E, F, G, H, I, H, okay lah, G, H, I. Okay, so always take this one then this one. So your first answer will be 1A plus 2D plus 3G. Second answer, this one is first row, second column. So you take the first row times the second column. So 1 times B plus 2 times E plus 3 times H. This one is first row, third column. So first row, third column. The first one is always row. The third one is always column. So 1 times C, 2 times F, and then 3 times I. Okay, so this is how we do the multiplication lah. Okay, so I continue a bit. So just now is So answer for linear equation, system of linear equation. So this one is called numerical solution to non-linear equation. Non-linear equation, that means your system here is not straight line. Both of it is not straight line. This one, okay, if you draw in 3D, it is a straight line. Okay, but this one now no more straight line. It is a curve. Okay, we don't know how it's a curve. It can be straight line, it can be curve. But this method is specifically for curve. Okay, but straight line also can solve. Just no need to use such complicated way in order to solve lah. Okay, so now we have a look. Just roughly have a look lah. Okay, so we have few methods. First one is called graphical method. So what is graphical method is we try to plot. This one is not easy lah. Okay, we try to plot. We try to plot both line. Okay, we try to plot both line. The first one will give you the circle. Okay, the second one will give you this line. So we try to find what is their intersection point. And then the intersection point will tell you what is the answer. But this one is approximate. Because if you don't have any tools, you don't have MATLAB, you don't have Maple, you don't have GeoGebra, then what you have is only a very rough answer. Okay, so agak-agak only. Okay, so this one is called graphical method. And then direct interaction method. Okay. So direct interaction method. So firstly, let's say we have this equation. Okay, and then we'll try to write from the first one I get the x1, from the second one I get the x2, until the last one I get the xn. Okay, depend on how many equation you have, and then we try to do this one. We try to do the iterative. This iterative is a bit similar to Jacobi. Okay, it's a bit similar to Jacobi. So we have a look. What is this? Okay, this one later we'll see what is this. Okay, we'll try to have a look for this example. So we consider we have these two equations. Okay, we consider we have these two equations, and then from graphically we get roughly the answer is here. Okay, the answer is here. So this one will be our initial guess. Okay, so from the first one, I try to get the x. What is the x? 4 minus y2 and then square root. So that's why I have this one. Okay, but because it's negative, so I put the negative. Because square root can be positive, can be negative. So that's why you have two answer. Okay, and then second one, I get the y. So I move my ex to the back. So 1 minus ex. So this one will be my y. Okay, so I have these two, then the starting point will be here. Okay, so in order to use a direct iteration, we need to check their differentiation whether their sum of differentiation whether is less than 1 or not. Okay, so what we do here, we differentiate this one with respect to x, plus we differentiate this one with respect to y. Okay, and then we put in the x and y to see whether your initial point is suitable or not. Okay, so after we put in is less than 1, so okay. And then we differentiate this one with respect to x, with respect to y again, and then we put in our x and y, see whether it's less than 1 or not. If less than 1, yes, that means this initial point is suitable for these two. Okay, and then we can start with the direct iteration. Okay, we can start with the direct iteration. So do until there are nothing, there are very less change. Okay, then the answer will be this one. Okay, for 2 also the same, but because you are starting with different points, so you have to substitute to check whether it's correct or not. Okay, it's still less than 1 or not. If less than 1, then only you can proceed. Okay, so this one you can have a look, and then next week we will try to do the tutorial 4. Okay, so any question for me before I end the class? Sorry lah, because I have to go out now, so I have to end the class earlier lah. Okay, maybe later we can extend a bit lah the class. So any questions? So, okay, if no questions, then see you again next week lah. Thank you, class. Next week will be week 8, is it? Alamak, you all left already. Never mind, later I discuss in the WhatsApp. Later I discuss in the WhatsApp, okay?